Welcome to this video lecture on electronic partition functions in the Unit 1 Statistical Thermodynamics of Physical Chemistry 2 paper in MSc Chemistry course at Dr. MGR Educational and Research Institute. In this video, we are going to derive the electronic partition function. The general expression for electronic partition function can be given by Q electronic is equal to summation over I of GE exponential power minus EE divided by KBT. So let us consider this as equation 1. Now what all these terms means we will see. QELE is Q electronic, which means electronic partition function, and GE is the degeneracy for electronic energy levels, and the E suffix E, that is the epsilon type E, is nothing but the energy. So E suffix E refers to the energy of electronic levels. Now I represents the levels and Kb is the Boltzmann constant, and we know T is the temperature. Now this can be expanded as Q electronic is equal to G naught E exponential power minus E naught divided by KBT plus G1 exponential power minus E1 divided by KBT plus G2 exponential power minus E2 divided by KBT plus G3 exponential power minus E3 divided by KBT, and so on. Now from electronic studies, it is found that for most molecules the excited electronic energy levels lie so far above the ground state compared to KBT value. That is, the electronic levels are separated so far, and rather choosing the transition, the electrons or the particles remain in the ground state itself. So the molecules may be considered to be occupied in the ground state at ordinary temperatures. The above equation, that is the expanded equation, is considered to be equation 2. In equation 2, we have written G0, G1, G2, which means those are the degeneracy at levels of ground state, first electronic state, second electronic levels, so on. So when we see that equation, the second and third and subsequent terms are negligible, because we already told that the energy levels are so far apart and we are neglecting them. That is, the energy of the first state is very less than the energy of the second level or the energy of the third level. So the energy at the higher levels are more compared to that of the ground state energy level. So we are writing the equation 2 as Q electronic equal to G naught, that is G0, into exponential power minus E naught divided by KBT. So we are considering only the ground state level for this. If the energy of ground state is assumed to be 0, then that is E naught is equal to 0. It is closely to 0, so we consider it as E naught equal to 0. Then equation 3, the above equation becomes Q electronic is equal to G0 exponential power minus 0 by KBT. So anything to the power 0 is 1. So the equation gets down to Q electronic equal to G naught or G0, which is nothing but the degeneracy of the ground electronic state. So we can say that the electronic partition function becomes equal to the degeneracy of the ground electronic state. Now from equation 4, we understand that Q electronic, that is the electronic partition function, is equal to the degeneracy of the ground electronic state. Now how to find this ground electronic state? By Russell-Saunders coupling scheme, we know that degeneracy of an atomic electronic state is given by G naught is equal to 2J plus 1. This J is the total angular quantum number, and that can be written as L plus S. So this L plus S is the total angular quantum number, and this is applicable for atoms of atomic number less than or equal to 30. So for using this, we can find out the partition function value for electronic levels. The video lecture for electronic partition function derivation ends up here. For references, you can refer to quantum chemistry textbooks. The references used to prepare this video lecture are listed here. Thank you so much.